Alrighty folks, so this is the problem that was sent home tonight, and the reason I'm doing this video is to assist students in breaking this down. So here we have a composite shape, and we're practicing our skills in finding the volume, because our goal is to find the volume of the entire shape, and we need to pick this thing apart. So we have two identical cones on the top and bottom of this shape. The height of this cone is 6 centimeters. The height of this cone is 6 centimeters. And because they have the same radius from this cylinder, and the cylinder has a radius of 7 centimeters, they're the exact same cone on the top and bottom. So what's nice about this is when we're finding the volume, we just find the volume of one cone and double it. All right, good. So then we just need to figure out this cylinder shape also in the middle. We know its radius, but we don't know its height. We know the height of the entire shape is 21 centimeters, and if we take away 6 centimeters for each of the cones, that's a total of 12 centimeters, leaving us only 9 centimeters for the height of the cylinder. So that's going to be our first step. That's our first obstacle to overcome. Now we're ready to start finding volume. And we have two shapes here. We have the volume of the cone, and the volume of the cone is going to be 1/3 times radius squared, which is 7 squared, 1/3 because it's a cone, times the height of the cone, which is 6, times pi. So we have the area of the base, which is r squared times pi. We have the height of the figure, which is 6. And then because it's a cone, we take 1/3. So that's our formula. We're going to use that formula here in a minute. Actually, you know what? I'm going to go ahead and let you use that formula. I'm going to get you guys prepped to solve this out, but I know you guys can do this. Then we're going to, after you finish that, you can either do it twice and add them together, or finish this answer and multiply it by 2. Okay, then we need the third shape, and the third shape is the volume of the cylinder. Okay, the volume of the cylinder is radius squared, 7 squared, times the height of the cylinder, which we just found, times 9, times pi. Okay, we just moved it around a little bit. R squared times pi, that's the area of the base. 9 is the height. Now that's the volume of the cylinder. So now you just have to solve those and then add them together, because you need to add the shapes of the two cones and the cylinder all together to find the volume of the entire shape. All right, so we're going to find volume, and we've been doing this in class in terms of pi, which means we are not going to substitute pi. So let me go ahead and move these equations into another slide. Let's see, right here, and then copy. Okay, so here we have our, please go away. Here we have our equations, and now we just need to simplify them out. All right, in terms of pi. So first we have volume of the cone is 1/3 times 7 squared times 6 times pi. All right, radius squared times pi times height, and then times 1/3 because it's a cone. Awesome. So we're going to do a little bit more movement. We can move these factors around because of the commutative property of multiplication. And I'm going to go ahead and square, actually before I move anything, I'm going to go ahead and square 7. So that's 49. Now you can just put this into your calculator. That would be fine. But mental math, I'm going to say, hey, wait a minute. If I can move this 6 over here by the third, 1/3 of 6 is 2. And I can do 2 times 49 in my head. That is 98. So I know the volume of the cone is 98 pi centimeters cubed. Okay? Now, if you're not sure how I figured that out, took 1/6 times 1/3, or 6 divided by 3, not 1/6, just 6. 6 divided by 3, or 6 times a third. Either way, that gives me 2. 2 times 49 is 98. Now, if you did 49 times 6 divided by 3, you will also get 98. All right? So that's the volume of our cone. Next, we're going to do, that's the volume of the cone. Next, we're going to do the volume of our cylinder. Very, very similar, but it had a different height. Remember, our cylinder had a different height. So here we're going to do volume that's supposed to be a cylinder. Volume of a cylinder is 49, that's 7 squared, times 9, times pi. Radius squared times pi is area of the base times height. We're good. Okay, now 49 times 9, that's the same thing as 50 times 9, which would be 450, minus 9. So that's volume of the cylinder is 450 times minus 9, so 441 pi. Okay, so now we have a couple options. We know we have 2 cones, cone on the top, cone on the bottom. We have 1 cylinder in the middle. So let's go ahead and keep things simple and just add them together. And let's add them in the way, in the order that they are in the sheet. So we're going to do volume of the cone. Oops, I forgot centimeters cubed. Can't do that. Volume of the cone is 98 pi centimeters cubed. And we're going to add that to the volume of the cylinder, which is 441 pi centimeters cubed. And then we have another cone on the bottom, which is 98 pi centimeters cubed. Add all that up together. That gives us a 7 here, 119.3 to 637 pi centimeters cubed. Now, as we add all those up, it is really nice. That's the volume of our weird shape down here. Okay. It's really nice to be able to do that without having any decimal versions because we substituted for pi. It's all in terms of pi. So the volume of our really big composite shape is 637 pi centimeters cubed. Now hopefully you gave this a shot and then watch the video to see if you got it right. If you didn't get it right, redo it. If you did get it right, give yourself a high five. But that's how we're going to find the volume of this shape. You got 3 different pieces going on. The volume of this shape by finding the individual cone and the individual cylinder and adding them together. Hopefully all my math is good and this was a helpful video for you. If you have any questions, please ask.